Hello dear students, welcome back to the online CET classes. This is the next concept of the topic. Today I am going to discuss the problems on the subtopic uniformly accelerated and non-uniformly accelerated motion. The first question is like this. Refer your notes or CET material. The question number 18. In previous class already I discussed the past competitive multiple choice questions and applied multiple choice questions on the basis of distance, displacement, speed and velocity. And today I am going to continue the next sub concept of this topic, that is uniformly accelerated and non-uniformly accelerated motion based problems. The first problem is like this. A body of mass 10 kg is moving with a constant velocity of 10 meter per second. A body of mass 10 kg is moving with a constant velocity of 10 meter per second, u equal to 10 meter per second. And when a constant force acts for 4 seconds, a constant force acts for 4 seconds, that is t equal to 4 seconds on it, it moves with a velocity 2 meter per second in opposite direction. 2 meter per second in opposite direction, that is v is equal to minus 2 meter per second. The acceleration produced in it is, the problem is like this. A body of mass 10 kg. Suppose if you consider this is the body of mass, m is equal to 10 kg moving with a constant velocity of, that is u equal to 10 meter per second. When a constant force acts for 4 seconds here, the force acting on this body, that is t is equal to 4 ಸೆಕೆಂಡ್ 4 ಸೆಕೆಂಡ್ಗಳ ಕಾಲ ನಾವು ಇದರ ಮೇಲೆ ಕಾನ್ಸ್ಟಂಟ್ ಫೋರ್ಸ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿದಾಗ it moves with a velocity of 2 meter per second, that is the final velocity v equal to 2 meter per second in opposite direction. The acceleration produced in it is, we know that the simple formula, that is the first kinematic equation, v is equal to u plus at. From using this formula, now I am going to calculate the value acceleration. A is equal to v minus u divided by t. Therefore a is equal to v minus u divided by t. V minus u, here it is in opposite direction, here it is minus 2. The negative sign indicates it is in opposite direction. V minus u divided by t, that is minus 2 minus 10 divided by 4. Minus 2 minus 10 divided by 4. Therefore a is equal to minus 2 minus 10, that is minus 12 divided by 4. Here a is equal to 4 1s and 4 3s. A equal to minus 3 meter per second square. A equal to minus 3 meter per second square is the right answer for this question. The acceleration produced in it and the body of mass 10 kg is moving with the constant of 10 meter per second. The right answer is option D, that is minus 3 meter per second square. And the next question, that is question number 19. The average speed of a body moving with uniform acceleration traveling a distance of 3.06 meter is 0.34 meter per second. If the change in velocity of the body is 0.18 meter per second, during this time its uniform acceleration is, during this time the uniform acceleration is, the average speed of the body moving with the uniform acceleration traveling a distance of, we know the formula, time is equal to distance divided by average velocity. Time is equal to distance divided by average velocity. Here the distance is 3.06 meter divided by average velocity is 0.34 meter per second. 3.06 divided by 0.34 meter per second, we get the answer is 9 second. Time t is equal to 9 second. If the change in velocity of the body is, that is 0.18 meter per second, during this, the uniform acceleration A is equal to velocity divided by time. But here A is equal to change in velocity. A is equal to change in velocity divided by time. The change in velocity is, that is 0.18 meter per second divided by the time t value is 9 second. 0.18 divided by 9 is, we get the answer 0.02 meter per second square. A is equal to 0.02 meter per second square. The right answer for this question is option B. Option B is the right answer for this question. And the next question is, that is question number 20. The displacement of a particle varies with the time s equal to a into t square minus b into t cube. The acceleration of the particle at any given time t will be equal to. Here the displacement equation is like this, that is s equal to a into t square minus b into t cube. The acceleration of the particle at any given time. The acceleration of the particle at any given time will be equal to s equal to at square minus bt cube. The acceleration, the given equation is displacement. And what is velocity? Velocity is equal to the rate of change of displacement, that is v is equal to ds divided by dt. Therefore d divided by dt into differentiation of at square minus b into t cube. At square minus b into t cube. It is in the form of d into x to the power of n divided by dt. We know that formula, d into x to the power of n divided by dt means differentiation of x to the power of n divided by dt is equal to n into differentiation of x to the power of n minus 1 into dx. N minus 1 into dx. Therefore, v is equal to, it is in the form of a into t square dx to the power of n. N means 2. 2 into a into t, a into t, it is a constant value, 2at minus 3 into b t square n minus 1 t square. Here 2 minus 1 is 1. 2a to the power of 1 minus 3 bt square. This is the velocity. V is equal to 2at minus 3 into bt square. But the acceleration a is equal to dv divided by dt. This is equation number 1. When we differentiate again this equation, we get a is equal to dv divided by dt. dv divided by dt means again differentiate this equation, we get 2 into a. There is no value for this question, 1 to the power of 1, that is value 0. Here the n value is 1. 1 into 2a is 2a. 2a minus, here this is the n. N means 2. 2 into 3 is 6. 6b into t. 2 minus 1 is 1. 2a minus 6b into t. 6b into t. Therefore, a is equal to, or we can write this equation, 6bt is equal to 2a minus a, or t is equal to a divided by 3b. T is equal to a divided by 3b. The option B is the right answer for this question. T is equal to a divided by 3b. And the next question is, that is the question number 22. The question number 22. The velocity of a particle at an instant is, the velocity of a particle at an instant is 10 meter per second, After 5 seconds, the velocity of the particle is 20 meter per second. Find the velocity at 3 seconds before from the instant when velocity of the particle is 10 meter per second. Here the given values are u equal to 10 meter per second. After 5 seconds means t is equal to 5 second. The velocity of the particle is 20 meter per second, that is final velocity 20 meter per second. Find the velocity at 3 seconds before from the instant when the velocity of the particle is 10 meter per second. First we are going to find the acceleration value. Again you know the formula, A is equal to V minus U divided by T. V is 20 minus 10 divided by 5. Therefore A is equal to 20 minus 10 is 10 divided by 5 is 2. A is equal to 2 meter per second square. A is equal to 2 meter per second square. But we know the velocity at 3 seconds before from the instant. Now I am going to calculate that value, that is V1 is equal to U1 plus AT. Here velocity of the particle is, that is 10 meter per second, equal to U1 plus acceleration value is 2. 2 into here the 3 seconds before 3. Therefore 10 equal to U1 plus 3 into 2 is 6. Therefore U1 is equal to 10 minus 6. U1 equal to 10 minus 6 and U1 equal to 10 minus 6 is 4. 4 meter per second. U1 equal to 4 meter per second. Option B is the right answer. U1 equal to 4 meter per second. And the next question is, that is the question number 25. The question number 25. Which graph corresponds to an object moving with a constant negative acceleration and positive velocity? Negative acceleration and positive velocity. Here, according to this question, object is moving with constant negative acceleration. Constant negative acceleration, that is A is equal to minus constant. A equal to minus constant. A is equal to minus constant. But here the positive velocity, that is V into dV divided by dx. V into dV divided by dx means the double differentiation of the velocity, we get the acceleration. V into dV divided by dx is equal to minus c, or V into dV is equal to minus c into dx. Minus c into dx. When we differentiate this equation, we get minus c into dx is equal to v square divided by 2, or it is minus cx plus k. Therefore x equal to minus v square divided by 2c plus k divided by c. Here this graph corresponds to an object moving with the constant negative acceleration. Constant negative acceleration with the positive velocity, x equal to v square divided by 2c plus k divided by c. Hence the graph C represents correctly here. The graph C, it represents correctly. The next question is, that is question number 26. Metro station metro train starts from rest and in 5 seconds achieves a speed 108 km per hour. After that, it moves with a constant velocity and comes to rest after traveling 45 meter with uniform retardation. Retardation means opposite, negative. If the total distance traveled is 395 meter, find the total time of traveling. Find the total time of traveling. Here There are totally three parts. A metro train starts from rest. Suppose if you consider the metro train, it starts from rest, u equal to 0. And in 5 seconds, time t1 is equal to 5 seconds. It achieves a speed of 108 kilometer per hour, right? And after that it moves with the constant velocity, means that is 108 kilometer per hour, and comes to rest after traveling 45 meter, s equal to 45 meter with uniform retardation. If the total distance traveled is 395 meter, total distance travel is 395 meter. Find the time of traveling, total time of traveling, the total time of traveling. Here, in the first part, the initial velocity u equal to 0, time t is equal to 5 second, and velocity v equal to 108 kilometer per hour. I converted kilometer per hour into meter per second, 108 into pi by 18, we get the answer 30 meter per second. Therefore, V is equal to U plus 80. V equal to U plus 80. V equal to U plus 80. V is 30 meter per second equal to V is 30 meter per second, and initial velocity it is at rest 0 plus A into time t is equal to 5, and A is equal to 30 divided by 5, that is 6 meter per second square. A equal to 6 meter per second square, and then the distance traveled is 395 meter, but we know the equation s equal to ut plus half at square. Initially the body is at rest, u equal to 0 into t, that is 0, 0 into t, whole term is 0 becomes then 1 by 2 into a value is 6 into time value is 5 second, 5 square, we get the answer s is equal to 75 meter. This is in the first part. And in the third part, in the third part, s equal to 45 meter. Here, rest after traveling 45 meter, s equal to 45 meter, and u equal to s equal to 45 meter, u equal to 30 meter per second. Starting from rest means this velocity 30 meter per second, and the final velocity is 0 because it comes to rest after traveling 45 meter. Therefore, a is equal to v square minus u square divided by 2s equal to minus v square, that is 30 into 30 divided by 2 into 45. Therefore, a is equal to minus 30 into 30, 900, 900 divided by 90, a equal to minus 10 meter per second square. A equal to minus 10 meter per second square, and then v is equal to u plus 80 is equal to final velocity is 0, 0 equal to 30 minus 10 into t, therefore t is equal to 3 seconds. And in the third part, the total distance traveled, that is s is equal to s1 plus s2 plus s3. The total distance traveled by the metro train starts from rest is, that is 395 meter, is equal to s1 equal to, here s1 is 75 meter, plus we don't know the s2 value, s2 plus s3 is 45 meter, s3 is 45 meter. From using this equation we get s2 is equal to 275 meter, s2 is equal to 275 meter, and the time of traveling, the time of traveling, here distance is equal to speed divided by time, time is equal to distance divided by speed. Distance is 275 divided by speed is 30. 275 divided by 30 is, that is 9.16, 9.16, nearly about it is 9.2 second. T is equal to 9.2 second or 9 second. Option, sorry, yeah, this is the time t, and the total time t is equal to t1 plus t2 plus t3. Here t1 is 5 second plus t2 is 9.2 second plus t3 is 3 second. The total time is 17.2 second. The total time is 17.2 second. Option D is the right answer. This is a very lengthy question, and these types of questions are asked in your JEE advanced examination. JEE advanced examinations. Okay, and the next question number, that is question number 27. Question number 27. The distance traveled by a body moving along a line in the time is proportional to t cube. We know the formula. S is directly proportional to t cube. Distance along a line, that is the displacement, is directly proportional to cube of its time. Here the time and the distance, they are directly proportional to each other. But by double differentiation of the displacement, we get the acceleration. By double differentiation of the differentiation, here v is equal to ds divided by dt. Here s is, that is t cube divided by dt. Therefore v is equal to 3 into t square, and a is equal to dv divided by dt, differentiation of the velocity. A equal to dv by dt means a is equal to d into 3t square divided by dt, or a is equal to 6 into t. A is equal to 6 into t. The A is directly proportional to t. Acceleration is directly proportional to time. If the acceleration is increases, the time is also increases. If the acceleration is decreases, the time is also decreases. Here, the graph B represent accurately the acceleration is increases, the time t is also increases. Option B is the right answer. But here the acceleration is decreases, time is increases. Here also the acceleration is decreases, time is increases. Here this is the body moving with the uniform acceleration. That's why the acceleration time graph for the motion of the body will be, when it is travel moving along the line in the time is proportional to t cube. Here this graph is the right answer. Option B is the right answer for this question. And the next question is, a person climbs up a stalled escalator in 60 seconds. ಒಂದು ಎಸ್ಕಲೇಟರ್ ಆರ್ ಎಲಿವೇಟರ್ ಅಂತ ಕರಿತೀವಿ ನಾವು. ಎಸ್ಕಲೇಟರ್ ಮೀನ್ಸ್ ಎಲಿವೇಟರ್. ನೀವು ಹೋಗಿ ಅದರ ಮೇಲೆ ನಿಂತ್ಕೊಂಡ್ರೆ ಅಂದ್ರೆ ಅದ್ರ ಮೇಲೆ ಮೂವ್ ಆಗುತ್ತೆ. ಇಟ್ ಇಸ್ ಒನ್ ಟೈಪ್ ಆಫ್ ಲಿಫ್ಟ್ ಆಲ್ಸೋ. ಇಟ್ಸ್ ಕಾಲ್ಡ್ ಎಲಿವೇಟರ್. Person climbs up a stalled escalator or elevator in 60 seconds. If standing on the same but escalator running with the constant velocity, he takes a 40 seconds. How much time is taken by the person to walk up the moving escalator? Moving escalator ಮೇಲೆ ಅವನು ವಾಕ್ ಮಾಡಬೇಕಾದ್ರೆ ಎಷ್ಟು ಟೈಮನ್ನು ತಗೋತಾನೆ ಆ ವ್ಯಾಲ್ಯೂವನ್ನು ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಹಿಯರ್ ಅ ಪರ್ಸನ್ ವಾಕಿಂಗ್ ಓನ್ಲಿ ಈಸ್, that is 60 seconds means 1 divided by 60. 1 by 60, that is escalator divided by second. 1 escalator divided by second, 60 seconds. If standing the escalator without walking the speed is, that is 1 by 40. 1 by 40 escalator divided by second. These are the two values, 40 and 60. Right? But walking with the escalator going, the speed is add, that is 1 divided by 60 plus 1 divided by 40 is equal to 1 divided by 60 plus 1 divided by 40. Then we get the answer 60 plus 40. 60 plus 40 is 100. 100. Then we get the 60 plus 40 is, sorry, 60 plus 40 is 120. 60 plus 40 is 120. We get the answer, when you take the LCM, we get the answer 15 divided by 120. 15 divided by 120 escalator divided by second. And the time to go up to the escalator, that is t is equal to 120 divided by 5. T is equal to 120 divided by 5. 120 divided by 5 is that is 24 second. Option C is the right answer for this question. And next question is the question number 33. Here the question number 33 is like this. A point moves in a straight line. Point moves in a straight line under the retardation AV square. If the initial velocity is u, the distance covered in t second is. The distance covered in t second is. Here the retardation is given by retardation, that is dv divided by dt is equal to minus AV square. Integration between the proper limits. Now this is equation number 1. Integrate this equation number 1 between the proper limits from initial velocity u to final velocity v. We get the answer. Integration between the proper limits u to v, rather take the negative value outside, that is dv divided by dt, or dt it is v square. dv divided by v square is equal to integration between the limits of time 0 to t a into dt. Here take the velocity values this side and time value in the real in this equation. When you are integrate, this equation becomes dv divided by v square is 1 by v is equal to at plus 1 divided by u. at plus 1 divided by u, or it is dt divided by dx is equal to a into t plus 1 divided by u, or dx is equal to u into dt divided by 1 plus a into u into t. Here when you are integrate between the proper limits, again integrate this equation between the proper limits, that is integration from 0 to distance x, and this is from 0 to time t. We get the answer s equal to 1 divided by a into ln of 1 plus a into u into t. S is equal to 1 divided by a into ln of 1 plus a into u into t. The option C is the right answer for this question. This is the lengthy question and it is very difficult to understand at this level. Try to some more problems on the basis of the differentiation and integration for your future reference. Okay, option C is the right answer. And the next question is, that is the question number 34. A body covers 26, 28, 30, 32 meters in 10th, 11th and 12th and 13 seconds respectively. The body starts here 26 to 28, the 2 is difference, 28 to 32 is difference, 30 to 32, 2 is difference. Here 10 to 11, 1 is different, 12 to 11 to 12, 1 is difference, and 12 to 13, 1 is difference. From rest moves with the uniform velocity, option A, and option B from rest and moves with the uniform acceleration, and option C with an initial velocity moves with the uniform acceleration. This is option C. And option D is with an initial velocity and moves with the uniform velocity. These are the four options. And body covers 26, 28, 30 and 32 meters, that is distance, in 10, 11, 12 and 13 seconds respectively. It means body moving with the initial velocity. And moves with the uniform acceleration. Acceleration means rate of change of velocity. Here the velocity changes continuously with respect to time. That's why option C is the right answer. Because the distance covered in the nth second, that is Sn is equal to u plus 1 divided by 2 into 2n minus 1 into a. Sn is equal to u plus 1 by 2 into 2n minus 1 into a. Option C is the right answer for this question. Option C is the right answer for this question. And the next question is the question number 37. This is the one type of different problems. Dear students, ನಾವು ನಿಮಗೆ ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ ಮಟೀರಿಯಲಲ್ಲಿ ನಾನು ಆಲ್ರೆಡಿ ಸಾಲ್ವ್ ಮಾಡಿರ್ತಕ್ಕಂಥ ಫಾರ್ಮೆಟಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಇತ್ತು ಅಂದರೆ ನಾನು ಅದನ್ನು ಸ್ಕಿಪ್ ಮಾಡಿರ್ತೀನಿ. ಓಕೆ, ಸಾಕಷ್ಟು ಎನ್ ನಂಬರ್ ಆಫ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇರ್ತವೆ. ಸ್ವಲ್ಪ ಪ್ರಾಬ್ಲಮ್ಸನ್ನು ನೀವು ಕೂಡ ಹೋಮ್ವರ್ಕ್ ಮಾಡಬೇಕು. ಒಂದೇ ರೀತಿಯಾಗಿ ಪ್ರಾಬ್ಲಮ್ಸ್ಗಳಿದ್ದಾಗ ನಾನು ಅವುಗಳನ್ನು ಸ್ಕಿಪ್ ಮಾಡಿರ್ತೀನಿ, ನೀವು ಅದನ್ನು ಮನೆಯಲ್ಲಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು. ನೆಕ್ಸ್ಟ್ ಟೈಪ್ ಆಫ್ ಪ್ರಾಬ್ಲಮ್ ದಟ್ ಈಸ್ ಬುಲೆಟ್ ಫೈರ್ಡ್ ಇಂಟು ಎ ವುಡನ್ ಬ್ಲಾಕ್ and loses half of its velocity. Suppose if you consider this is the wooden block and this is the bullet fired into a wooden block loses half of its velocity. Suppose initially it moves with a 30 meter per second. Let's just imagine half of its velocity after penetrating 40 centimeter. ಇದರಲ್ಲಿ 40 ಸೆಂಟಿಮೀಟರ್ ಎಸ್ ಈಕ್ವಲ್ ಟು 40 ಸೆಂಟಿಮೀಟರ್ ಮೂವ್ ಆದಮೇಲೆ, ಹೌದಾ, ಹಾಫ್ ಆಫ್ ಇಟ್ಸ್ ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ ಮೀನ್ಸ್ ವಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಾಯಿತು 15 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್. ಇಟ್ ಕಮ್ಸ್ ಟು ರೆಸ್ಟ್ ಆಫ್ಟರ್ ಪೆನೆಟ್ರೇಟಿಂಗ್ ಅ ಫರ್ದರ್ ಡಿಸ್ಟೆನ್ಸ್. ಇನ್ನೊಂದಿಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಹೋದ್ಮೇಲೆ ಫೈನಲ್ ವೆಲಾಸಿಟಿ ವಿ ಈಕ್ವಲ್ ಟು ಏನಾಗ್ಬಿಡ್ತು 0 ಆಗುತ್ತೆ. ರೈಟ್, ಇಲ್ಲಿ ಕೇಳ್ತಕ್ಕಂಥ ಕ್ವಶನ್ ಅಂದರೆ ಫಾರ್ ದ ಫಸ್ಟ್ ಪಾರ್ಟ್ ಆಫ್ ಪೆನೆಟ್ರೇಷನ್, ಫಾರ್ ದ ಫಸ್ಟ್ ಆಫ್ ಪೆನೆಟ್ರೇಷನ್ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ನಮಗಿರ್ತಕ್ಕಂಥ ಇಕ್ವೇಷನ್ ವಿ ಸ್ಕ್ವೇರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಯು ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 2as. ವಿ ನೋ ದಟ್ ದ ಆ್ಯಕ್ಚುಯಲ್ ಫಾರ್ಮುಲಾ ವಿ ಸ್ಕ್ವೇರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಯು ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 2as ಆರ್ ವಿ ಸ್ಕ್ವೇರ್ ಮೈನಸ್ ಯು ಸ್ಕ್ವೇರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 2as. ವಿ ನೋ ದಿಸ್ ಫಾರ್ಮುಲಾ. ಹಿಯರ್ ವಿ ಸ್ಕ್ವೇರ್ ಈಸ್ that is u divided by 2 whole square, because bullet is fired into a wooden block, loses half of its velocity after penetrating 40 centimeter ಆದಮೇಲೆ half of its initial velocity ಅಂದರೆ u divided by 2 whole square minus initial velocity we don't know u square is equal to 2as, and here a is equal to minus 3 into u square divided by 8s. When you are solve, we get this equation. A is equal to minus 3 u square divided by 8s. That is equation number 1. For later part of the penetration, it comes to rest. That is final velocity minus initial velocities. That is u divided by 2 whole square. U divided by 2 whole square is equal to 2a into s dash, or s dash is equal to u square divided by 8a minus u square divided by 8a. Therefore, here s dash is equal to u square divided by 8a, or s dash is equal to minus u square divided by 8 into a is equal to, that is 8s divided by 3 into u square. 8s divided by minus 3 into u square. Therefore, s dash is equal to, here u square and u square get cancelled. U square and u square get cancelled. S equal to, that is 5 centimeter. Right? 8 into 5. 40. 40 divided by is. Therefore, we get the answer 40 divided by 3 centimeter. 8 and 8 cancel. S equal to 40. 40 divided by 3 second. S dash is equal to 40 divided by 3 centimeter. Sorry, it's the distance. 40 divided by 3 centimeter. Option B is the right answer. Okay. In the next class, that is the last class, I will discuss the problems on motion under gravity and relative motion problems to you people. Okay.